So introducing the const keyword. In this video we will be talking about const's meaning and how it depends on context. Generally it means I promise not to change this. What this is depends on exactly where it appears in a piece of code. At the end of a member function, for example, int getCurrentTryConst, it prevents the function from modifying any member variables. And this is a good safety feature. So let's dive in and take a look at it in action. So let's see how this useful protection mechanism actually works. So for example here in this getter, getMaxTries, you'd really hope that doesn't change anything. It just returns a number, right? But what I'm concerned about is at the moment it can change things. You don't need to reformat your code like I'm doing because I'm going to put it back in a minute. But I just want to show you that we can go myMaxTries, for example, in here equals, I don't know, 12. Not very nice, because that would be a horrible side effect. And the fact that it compiles and lets us do that concerns me. So what we can do is use something called const, where we declare getMaxTries.
Whenever you write a getter in future, I want you to write the word
const after it. And then, of course, in your definition, you're going to have to write const for it to match. And now const in this position, it depends where you put const as to what it does. It has a different meaning in different positions. But we're only talking about it on the end of a member function right now. So on the end of a member function, look what it does when we try and compile. Look at the errors. Expression must be modifiable. myMaxTries. We're not allowed to change myMaxTries. In fact, we're not allowed to change any of these member variables. Let's try changing myCurrentTry. Doesn't let us change it, okay? Equals 23. It's going to complain. Even if these things were public, myCurrentTry, which they shouldn't be because we want access to them through our nice methods, but if they were public, we still couldn't change it, which is absolutely good. Okay, so this is just protecting ourselves and from other people. So let's go back to where we were. Got const on the end there. I'm going to just get rid of this nasty code and prove that const in this position in the declaration has had the effect of making sure that this function, a member function, it has to be a member as part of a class, and I'll explain that in a second. In fact, I'll explain that now. Let's go to main. And if we try to make, for example, play game const, or let's try something else actually, print intro. Okay, so here's print intro. It turns out, don't do this, just watch for a second. It turns out you need to put it above. So there's print intro. If I go const here, look, I'm going to get another error. A type qualifier is not allowed on a non-member function. This is a non-member function because it's not inside a class declaration. Okay, these methods are all inside a class, this isn't. So this only works on class functions, if you like, or member functions is another way of calling it. You have to be a bit careful with these terms because strictly speaking in the C++ standards, they just talk about functions, but anyway. So over here, we've said const, and it prevents this method from changing any properties or variables of the object, which is really powerful.
Sam here with a little further example to help you understand why you might want to use const. Because you might have been saying up to this point, I don't quite see how it changes the functionality of the code. Well, it doesn't. It actually doesn't change the functionality at all. All it does is it puts a guard in place so that in future, if you forget that that function wasn't supposed to change any of the state in the class, it won't let you, and because you put const there, and it will make you think twice, and it will make anybody else think twice. Think about a situation in the future where you're debugging your code and trying to figure out where something has changed in your class. Automatically, if a method is const, you know you don't even have to look in it because you can't possibly have changed anything on the class from that method. However, if it's not const, you're going to have to go and look in it and check. And if you have to go and check in every single getter and double guess yourself all the time, it can be a real headache.
So, got a challenge for you. So your challenge is to apply const to all your other getters. Make all the getter methods constant, check it still runs, and I want you to answer this question in the discussions. Are any of the other functions we've written so far candidates for the use of const? If so, suggest which, if any, in the discussions. Just because I want to get you used to putting your ideas out there into thinking. Now, some of you may not feel comfortable with that, but I'd encourage you to do things you're a little bit uncomfortable with. So think if any of the others, and discuss with the other students, could we make one of these other methods that we've got already declared here, could one of these others be const, one of the three that I've highlighted? Okay, Go ahead, pause the video and do that challenge now. Cool. So, welcome back. Obviously, we're going to make get current try const because it's a pure getter. It's called const. It's called get, rather. It starts with get. We want to make it const. Now, there's another, of course, which is the is game one. If we're asking, we haven't implemented this yet, but from now on, I want you to start thinking about if we're just asking a question, is the game one, even though there is no definition of that yet, I want this to be constant, right? Because I know just contractually that looking at this, I don't want is game one to be changing anything. That would be bad, wouldn't it? I think it would be bad. Okay, so that's fine. Now I'm just going to move reset down because it's kind of a different class of method. This actually does stuff. So I'm going to move that down one, leave all these guys at the top, the constant ones at the top. I'm going to leave space here because I want you to stop looking at the private parts. Stop being obsessed with private parts, okay? Focus on the interface, which is getting clearer and clearer. Okay, these things don't change anything and now can't change anything, which is great. And then we can reset the game and check validity, which we'll implement later. Okay, let's compile. Always compile. Make sure things work. And nice, simple video. See you soon.